So PSE should be very under this curve. So PSE is 2 alpha into beta. So implies 2 alpha into beta. The area of this curve is 2 alpha into beta. PSE is equal to 2 alpha into beta. Equal to 20 alpha. Implies beta is equal to 10. So this is the final answer. Beta is equal to 10. Okay. In the question above, suppose the transfer function is changed to 10 to the minus 3 by j omega plus alpha. So previously we had a constant as the transfer function, but now we also have a complex transfer function. And the noise power is 10 to the power minus 10. To compensate for the channel distortion, the receive filter transfer function is chosen to be this thing. The receiver output SNR is required to be at least 35 dB, which is 3162. Determine the minimum required value of beta. So again, in question 7, the transfer here, the input is same. So the input signal has the message signal has a beta pi omega by 2 alpha, with alpha equal to 8000 pi. Beta equal to, so question 7. Hmm. This is the receive filter, and the channel is 10 to the minus 3 by j omega. So both of them will act on the signal by j omega plus. And Sn omega is 10 to the minus 10. So Ps out will be mod ht omega square mod hc omega ps in. So mod ht omega square will be so the output power will be so the output SNR will be 3162. The output SNR is given to be 3162. Mm. So when the signal power is 10 to the power minus 6 by alpha squared into PSE, and the noise power will be the power spectral density of noise into bandwidth. The bandwidth is 2 alpha, that is 2 into alpha, that is 2 into 4005. So right now we will keep it as alpha. This will be 3162. PSE will be 2 into 3162 into alpha cube. So this will be my PSA. And PSE is 2 alpha beta. So beta is equal to 3162 into 10 to the minus 4 alpha square. And alpha is given to be 8000 pi. So 3162 into 8000. So this works out to be, if alpha is 4000 pi, this works out to be 1.99 into 10 to the power 12. This needs to be rechecked. So okay, alpha is not 4000 but 8000. 8000 into 8000 into 316. The figure of merit. Okay, so moving on to question number 8. The figure of merit of AM is more than that of DSPSC. True or false? So here we have to find the figure of merit of AM. The figure of merit, as we know, is the ratio of the output SNR and the input SNR. SNR output by SNR input. So figure of merit for AM. The figure of merit for AM. For AM first. AM. In AM, the signal is given as NT 1 plus K cos omega CT AC. So the output is for SNR input will be AC square P, sorry, AC square the P, where P is the power of the message signal. P is the power of the message signal, and then it is mod of 1 plus K cos omega CT. So AC square P figure. Sorry, this was wrong. So this will be opposite. That's right, it was not matching. So AC cos omega CT plus into 1 plus KMT. So this will the power of signal input PS in is AC square by 2 into 1 plus K square P. So this is the input power. Okay, I'll be back in a few minutes. Let's take a break of 5 minutes. I'll be back in 5 minutes. কিরে যাত্রা প্ল্যানিং করছিস? हाँ अच्छा रहेगा. You can do without but अच्छा रहेगा. क्या दिल्ली या बॉम्बे कहाँ से? और ना एमिरेट्स दुबई. उससे नीचे नहीं है ये इसमें लिखे ना एलेक्स में लिखे ना एलेक्स में सस्ता होगा. स्विस इंटरनेशनल. स्विस इंटरनेशनल फ्लाइट कोड स्विस 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 देखिए. हाँ विस्तारा इंडिगो वो सब डोमेस्टिक पार्टनर है. बेसिकली तुमको विस्तारा इंडिगो क्या करेगा? बॉम्बे ले जाएगा या दिल्ली ले जाएगा या इस्तांबुल कहीं भी एक ले जाएगा एक बड़ा एयरपोर्ट में. कोलकाता में तो कुछ होता नहीं है तो उधर से फिर स्विस इंटरनेशनल तुम्हें एकदम जीरो ये ले जाएगा. बट ये 2 स्टॉप्स. ओ 1 स्टॉप जेनेवा नहीं है क्योंकि स्विस इंटरनेशनल का हब ही है ना जेनेवा. तो इसीलिए आई थॉट सस्ता होगा बट ज्यूरिक के लिए सस्ता होता है. फिर तुमको ज्यूरिक से तो जेनेवा जाना ही पड़ेगा. उनका हब पे ज्यूरिक पे जेनेवा पे नहीं. इसके लिए लंदन के लिए फिर ट्रांजिट वीजा बनाना होगा. यूके के लिए यूके से जाओगे अगर यूके से जाओगे नहीं ना वो बामनवाड़ी काटेगा ही नहीं.
बंगलुरु को ये भी बोल देता है कि अगर ये करोगे तो रियम्बर्स नहीं होगा. बोलता है मैंने उसको बोला था कि मेरा पैसा इतना है मैं उसमें से टिकट कर सकता हूँ उससे ज्यादा नहीं कर सकता.
इसका अच्छा ये दिखाता है flightsgoogle.com बेटर दिखाता है. मोर इंटरेक्टिव है. আমি ক্লাস নিতে নিতে 5 মিনিট এগিয়ে এসেছি. हाँ NPTEL में CC. हाँ अरे बीच में 5 मिनट स्टॉप करके फिर से लेता हूँ भाई. किसको मन होता है पाँच सर दर्द करने लगता है 5-6 प्रॉब्लम्स के बाद এটা হবে হবে আচ্ছা এবারে স্টপ ওয়ান স্টপ অর ফিওয়ার এই হলো তোর টোটাল অপশনস ইফ ইউ ওয়ান্ট টু হ্যাভ অনলি ওয়ান লেওভার
পয়সা কত? আচ্ছা এটা কি ডিফারেন্ট ওয়েবসাইট ওয়াইজ ওরা অপটিমাইজ করে দেয় নাকি?
এটা আমার লবি থেকে রিকোয়েস্ট আলাদা হয়ে যাবে
হ্যাঁ ও তো কিছু চার্জেস নেবে নিজের নাকি?
চার্জেস ওর খুব কম বাট ও ওখানে রিফ্লেক্টই করে অন্য যে গুগল ওটা এগুলো কোনো ঠিক ঠিকানা নেই ডাইনামিক প্রাইসিং না যে কোনো সাইজ অনুযায়ী টাইম অনুযায়ী ডেট অনুযায়ী আইপি অনুযায়ী চেঞ্জ হতে থাকে সো ও একটা অন্যই প্রাইস কোট করবে তুই এখান থেকে প্রাইসটা দেখিস না এখান থেকে খালি রুটটা দেখ প্রাইসটা ওখানে গিয়ে যা হবে সেটা ফাইনাল তো রুট এইখান থেকে বেসিক্যালি মিডল ইস্ট হয়ে তার যদি ওয়ান স্টপে যেতে চায় হ্যাঁ এগুলো হলো ওয়ান স্টপ তো এই 31 আওয়ার্স গুলো অফকোর্স নিবি না 30 আর 14 এই দুটো তো ভায়াবল অপশন দুটো একটা দুবাই একটা দোহা সকাল 9টায় হ্যাঁ এইটা এইটা কাতার দোহার ওটা একটাই ফ্লাইট ছাড়ে ভোর 4টে নাগাদ যে যেখানে যাবে সবাইকে এইটাই চড়তে হয় আর আরেকটা আছে সকাল 10টায় এমিরেটস
কিভাবে ভোর 4টের সময় আচ্ছা
রাত্রেবেলা চলে যাবি কলকাতা লাউ যেতে লাউ কার্ড আছে তো ক্রেডিট কার্ড আছে তো
হ্যাঁ মানে আছে একজনের কাছে আছে
না ঝাপলে পাবি না
ঝাপলে পাবো না
কার্ডের মেমিসটা তো বোর্ডিং পাসের নাম মেলায় না তো বলতাম লাউঞ্জে থেকে এই দুটো যদি ওয়ান স্টপে যেতে আস আর যদি টু স্টপে যেতে চাস প্রচুর অপশন পাবি প্রচুর অপশনস আছে আলাদা অপশন আর এন্ডলেস অপশন আছে এন্ডলেস পারমুটেশন কম্বিনেশন বাট তুই ওয়ান স্টপ গুলোই ট্রাই কর
একই এক সেম
continuing on, the input power signal is AC square by 2 would be 1 AC square by 2 1 plus K square P. Now the message signal bandwidth, message signal noise power. The noise power depends on the message signal bandwidth and the PSD of noise. So it will be no, the bandwidth of this message signal, which is the bandwidth of B. Let's say bandwidth of the message signal B, we don't know, and N naught is the noise spectral power spectral density. So SNR input is AC square by 2 N naught B into 1 plus K square P. Now, for SNR output, we have to consider the demodulated signal. For gain, so the SNR output is AC square by 2 AC square by 2 1 demodulated signal. So here we will consider here the carrier will be eliminated. So only AC K M K cos omega CT will be there. So the power out here, since there is no carrier, it will be AC square K square P by 2, and the noise power is again N naught B. So the ratio of SNR out to SNR in is SNR out to SNR in, or the noise, the figure of merit or noise figure is AC square 1 plus K square P by 2 N naught B. This is the input, so this will be in below, and the output will be above in numerator, and it's AC square K square P by 2 N naught B. So if you cancel everything, it's K square divided by 1 plus A square. This is the figure of merit of AM. Now, the figure of merit of DSB-SC as derived earlier is 1. So Fm AM is equal to K square by 1 plus K square, which is clearly less than 1. Therefore, Fm AM is less than Fm DSB-SC. An unmodulated carrier of amplitude AC and frequency Fc is added to band limited white noise and passed through an ideal envelope detector. Assume the noise spectral density to be of height N0 by 2 and bandwidth 2W. So there is a carrier AC and FC are its parameters, and it is added to a band limited white noise and passed through an ideal envelope detector. Assume that the noise spectral density to be of height N0 by 2 and bandwidth 2W centered above the carrier frequency Fc. The output signal to noise ratio for the case when the carrier to noise ratio is high. Okay, so So xt is equal to so xt here will be the AC cos omega ct plus ni nt. Now we can break this into the quadrature component, the noise into quadrature and in phase components. So I and Q components. So this will be AC plus Ni cos omega ct plus NQ sin omega ct as carrier to noise ratio is high. AC NQ can be neglected. Therefore, envelope, since AC plus Ni cos omega t is what that remains, then the envelope of xt is AC plus Ni. And SNR of this is, since AC is the only useful component, the SNR will be AC square by the noise power, by half of the noise power, half noise power, because only the in-phase component is taken. So, what is the noise power? Noise power is the PhD into bandwidth. The PhD is given to be N0 by 2 and bandwidth is 2W. So, N0. So, this will be 2 plus the SNR will be 2 AC square by N0W. It will not be AC square by N2 N0W. It will be 2 AC square by N0W. So, it will be option A. This is given wrongly given as C. This will be option A. Consider a DSBC coherent demodulator whose local oscillator suffers from a phase error theta. If MT is a signal of bandwidth P with power P and channel noise PST M0 by 2, the output SNR is. So there is a DSBC coherent demodulator whose local oscillator suffers from a phase error theta. So the local oscillator generates a sinusoid that is theta phase shifted topology. Now, if empty is a signal of bandwidth B and power P and channel noise PHD is 1/2. So the signal bandwidth and signal power is given and the channel noise PHD is given. Then the output SNR is. So we have to find the output of a phase lagged demodulator for the DSBSC, and then so question 10. The output of the demodulator is the demodulator will have a half outside 1 plus half empty cos theta plus half Ni cos theta plus Nq sin theta. These are the noise components in phase and out of phase. Now the signal power. Signal is this part. Therefore, PS is, this is signal. So PS is cos square theta. Let the power of the signal be P. P cos square theta by 4. And what is the, this is the noise. So what will be Pn? Pn will be 1 by 4 root under Ni square cos square theta plus Nq square sin square theta. Now, this will eventually evaluate to N naught by this. Can also, since the noise spectral density and bandwidth is given, we can also write it as is equivalent to N naught by 2 into B. Therefore, the SNR is P cos square theta by 4 by N naught B by 2 is equal to P by N naught B P cos square theta by 2 N naught B. So the final answer will be P cos square theta. The final answer will be P cos square theta into N naught B. With this, so this will be option C. So the answer will be option C. With this, we will conclude today's lecture. Thank you for joining. See you on the next one. So PSE should be area under this curve. So PSE is 2 alpha into beta. So implies 2 alpha into beta. The area of this curve is 2 alpha into beta. PSE is equal to 2 alpha into beta. Root 20 alpha implies beta is equal to 10. So this is the final answer. Beta is equal to 10. Okay. In the question above, suppose the transfer function is changed to 10 to the minus 3 by j omega plus alpha. So previously we had a constant as the transfer function, but now we also have a complex transfer function. And the noise power is 10 to the minus 10. To compensate for the channel distortion, the receive filter transfer function is chosen to be this thing. The receiver output listener is required to be at least 35 dB, which is 3162. Determine the minimum required value of beta. So again, in question 7, the transfer here, the input is same. So the input signal has the message signal has a beta pi omega by 2 alpha, with alpha equal to 8000 pi. Beta equal to, so question 7. This is the receive filter, and the channel is 10 to the minus 3 by j omega. So both of them will act on the signal by j omega plus alpha. And Sn omega is 10 to the minus 10. So PS out will be mod HT omega square mod HC omega PS in. So mod HT omega square will be so the output power will be SNR will be 3162. The output SNR is given to be 3162. Mm. So when the signal power is 10 to the power minus 6 by alpha squared into PSE, and the noise power will be the power spectral density of noise into bandwidth. The bandwidth is 2 alpha, that is 2 into alpha, that is 2 into 4000 pi. So right now we will keep it as alpha. This will be 3162. PSE will be 2 into 3162 into alpha cube. So this will be my PSA. And PSE is 2 alpha beta. So beta is equal to 3162 into 10 to the minus 4 alpha square. And alpha is given to be 8000 pi. So 3162 into 8000. So this works out to be, if alpha is 4000 pi, this works out to be 1.99 into 10 to the power 12.